All right, here we go. 5.6, find rational zeros. Instead of doing a warm-up, I kind of thought I would do a little bit of a summary so far through Chapter 5. What you've done basically is deciding whether a function is a polynomial based on its exponents and simplifying powers, performing operations with polynomials, add, subtract, multiply, divide using synthetic substitution and division, recognizing types of polynomial graphs and describing their end behaviors based on the degree and leading coefficient, and using special factoring patterns and grouping and the box method to factor polynomials and find solutions or zeros to polynomials. Well, in this section, it's about using the constant term and the leading coefficient of a polynomial to make a list of all the possible rational zeros and then narrowing that list down to find the actual zeros. The last section you were given a zero and went from there. The theorem below will give you a starting point when you don't know any of the zeros. So it's actually, it's called the fundamental theorem of algebra, and what you're doing is find the zeros when the leading coefficient is 1. Basically all you do is you're going to use this little thing that summarizes down to P over Q. And what P is all the factors of the constant at the end of your polynomial. That's P. And Q are all the factors of the leading coefficient. And you're going to list all of P, all the factors of the constant, divided by all the factors of the leading coefficient to find all your possible rational zeros, and then narrow them down to find out the zeros of the polynomial. All right? So what P over Q does is it gives you all the possible rational zeros, meaning all of them that are not complex, which we're getting to still. All right, so first, let's just do this step by step. We have this polynomial function here. List the possible rational zeros of f using the rational zero theorem. So first I'm going to start by writing all the possible factors of my constant term, which is 20. So I have plus or minus 1 could be a factor, because let's say you have 20 times 1, both positive. You could also have negative 20 times negative 1, both negative. And I'm just going to kind of go in order. Plus or minus 2, 2 is also a factor. 4 times 5 are factors. Plus or minus 10, plus or minus 20. These are all the possible factors of 20. All right? So then, now we're going to list, and this is going to be my P, actually. These are my P. Now I'm going to list all the factors of the leading coefficient, which is my Q. And that's just 1, so that's easy. The only factors of 1 are positive 1 or negative 1. 1 times 1 or negative 1 times negative 1. So easy enough. Then what you need to do is you need to list all the possible rational zeros using P over Q. It creates that list of all the possible rational zeros. So this is kind of the long part where you go through and you take all your P's and write them over all your Q's. I went ahead and did that, and I just said, okay, I have plus or minus 1 over 1, P over Q, plus or minus 2 over 1, plus or minus 4 over 1, plus or minus 5 over 1, plus or minus 10 over 1, and plus or minus 20 over 1. So I listed all of them. Okay, so I listed all of the possible rational zeros. I'm not sure, something funky happened with the recording here. I just want to make sure you understood what I just said. So I did 1 over 1, 2 over 1, 4 over 1, 5 over 1, 10 over 1, and 20 over 1. And then I'm going to simplify this list right here. Since they're all divided by 1, I can just write them as plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, and plus or minus 20. Now, these are all the possible rational zeros all the possible places where this polynomial could hit the x-axis. What we need to do now is begin testing these possible solutions to find out which ones are the actual zeros. And what you do is you just start with choosing any of them and you do synthetic division to see if you end up with a remainder of 0. So let's start with positive 1. I'm going to set it up as synthetic division. So I'm going to test 1. Put 1 here. List the coefficients from my polynomial. They're 1, -8, 11, and 20. Do synthetic division here. This is 1, -7, -7, that's 4, and 4, 24. Since this is not 0, 1 is not one of my solutions. Okay, now don't be thinking we're going to go through all of these because things happen once you do find a 0. So now let's test -1 and see what happens. So I'm going to have -1. Okay, bring down the 1. This is -1. This becomes -9. -1 times -9 is +9. This becomes 20. -1 times 20 is -20, and this becomes 0. And voila, look at that. We have a remainder of 0, which means, yes, -1 is one of my solutions. So down here, I'm just going to start writing a list of solutions, just to kind of keep myself straight. So I know that -1 is one of my solutions. Now, I'm not quite done, because I know I'm going to have a couple more. But look what you have here now. You have 3 remaining, which means you have a trinomial, and you can write it like this. -1 is a solution, which means as a factor it's going to be written x plus 1. And then I'm going to write this trinomial here, x squared minus 9x plus 20, and all of that equal to 0. Now remember, this is the factor for this solution, because if I was to set that equal to 0, it would equal -1. So I just wrote that as a factor there. And then I wrote what I had left here as a trinomial. And I'm going to figure out if I can just go ahead and factor this trinomial so I don't have to actually go through all the division again and find out what those factors are so I can find out the rational solutions. Now, since this is a leading coefficient of 1, I'm going to look at the factors of 20 and say, do I have factors of 20 that add to -9? And I do. I have -4 and -5. So that means I can write the factored form of this trinomial as x minus 4 times x minus 5 equals 0. All right, so I already have that solution listed. If I were to set x minus 4 equal to 0, I would find out that another one of my solutions is +4. And if I set this factor equal to 0, another one of my solutions is +5. And I have determined the actual rational solutions for that polynomial using this little kind of cool method. Alrighty, so what you just did was you kind of found all the possible rational zeros of a polynomial with a leading coefficient of 1. Now what we're going to do is we're going to look at finding the zeros when the leading coefficient is not 1. And it's really the same method. We also might run into an instance where you get solutions that are not rational or real. And they might be irrational or they might be complex. So we're probably going to end up with an irrational one right now. And I'm going to show you a little trick to make it a little easier as well. So first of all, you have to remember that all the factors of 10 are going to be your q, which is going to be in the denominator here when we get to this point. And all the factors of 12 are going to be your p. So let's look at the factors of the constant term 12 first. We have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, 6, and plus or minus 12. Okay, and then let's look at the factors of the leading coefficient. This is where it gets a little messy because it kind of gets to be a lot, but we'll work through it. Factors of 10 are plus or minus 1, plus or minus 2, plus or minus 3. Oops, excuse me, not 3. Plus or minus 5, and plus or minus 10. Okay? All right, now we're going to list all the possible rational zeros, and there's a lot of them, because we have to take 1 and put it over 1, put it over 2, put it over 5, and put it over 10. So, I'm going to do that right now. I'm going to kind of list them out. Alrighty, so what I did was I took 1, I went over 1, then 1 over 2, because I'm doing P over Q. Remember, this is your P and this is your Q. And then 1 over 5 and 1 over 10. Now I have to do it for the 2's, but as I go, I'm going to check to make sure that I don't have any duplicates. So plus or minus 2 over 1 would just be plus or minus 2. Plus or minus 2 over 2 would be the same thing as 1, so I'm not going to write that again. Plus or minus 2 over 5. And plus or minus 2 over 10, which is the same thing as 1/5, and I already have that, so I'm not going to write that again. All right? So then I go to the 3's. Plus or minus 3 over 1 is just 3. And then plus or minus 3 over 2, I don't have that yet, that's 3/2. Plus or minus 3 over 5. And plus or minus 3 over 10. So I'm getting there. I'm going to just kind of take it over into the next row here because I have a lot more to go. So then I got to do the 4's. Plus or minus 4 over 1. Actually, I'll take it right here. Plus or minus 4. Plus or minus 4 over 2 is the same as 2, which I already have, so I'm not going to do that one. Plus or minus 4 over 5. And plus or minus 4 over 10, which reduces to 2/5, and I don't have that yet, so I'm going to write that down. Okay? Let's do the 6 now. 6 over 1, plus or minus 6. 6 over 2 is 3, which I already have. 6 over 5, plus or minus 6 over 5. And then 6 over 10, which reduces to 3/5, and I already have that. So I'm going to do the last one now, 12. Plus or minus 12. And then 12 divided by 2 is 6. I already have 6, so I'm not going to write that one down. 12 over 5, so plus or minus 12 over 5. And then 12 over 10, which would be 6 over 5. So actually what I did was I did step 3 and 4 together. This is my whole simplified list of possible rational solutions. So we don't need to do step 4. All right, this is where I'm going to make it a little bit easier here. Graph the function on the graphing calculator and choose reasonable zeros from the list above to test. Yes, you can get all the zeros from the calculator. However, I went to speak to Mr. Baird, and he said for pre-calc, he'll let you take 2 off the calculator and just prove the other 2 using our method down here. So I'm going to go ahead and pull out a graphing calculator. I put the equation in, so it's there. It's all there, I promise. And then I push graph. Now, I had to play with the window quite a bit, and I'll tell you what my window was that I had to get this, and so that you can get it on yours as well. Let me show you the window here. So I did -5, +5, 1, -10, and +10. And it took me a while to get those settings, but they seem to work really well. So when I go to graph it, I'm going to try and see if I can figure out exactly what a couple of these zeros are. So if you remember correctly, you want to use calculate here. So I'm going to go second calc. I want a 0. And it's blinking right here, so I'll see if I can just figure out what the 0 is. It's asking me if this is the left bound of that point right there, and it's not, so I'm going to arrow it above. There is to the left of the point I want. There's to the right of the point I want. And 0.6 is one of my zeros. And if you go back and you do 0.6 math as a fraction, it's +3/5, which is on my list. So I know that that is possibly one of the solutions. So I'm going to use that. 3/5 I'm getting from the calculator. Let me see if I can find another one then. I'll go back to my graph. Second calculate, I want to do another 0. So I'm going to take it over to this one here, because I think it's probably going to be -1/2, but I'm just going to kind of loop it around. Watch your y values. They'll go up, and then they'll start to come down again. So kind of look for it. And the calculator wants to know the left of the point, which is there. And then it wants to know to the right of the point, which is there. and it says yes, that 0 is negative 0.5, which is on my list, negative 1/2. So those are the two I'm going to start with. I'm going to go down here, and it says check the zeros you chose with synthetic division for a remainder of 0, just to make sure, and also to narrow it down, and to find the trinomial left after dividing those zeros as factors. So I know that these are solutions. I've got it off my list, and I checked it on the calculator, so I'm just going to go ahead and write them down here on the bottom as part of my solutions. And I'm going to have to find a couple more. First, I'm going to check it out. So I'm going to start with negative 1/2 and do synthetic division. My coefficients are 10, negative 11, negative 42, 7, and 12. Okay, bring down the 10. Half of 10, negative, is negative 5. This becomes negative 16. Half of negative 16 is positive 8. That becomes negative 34. Half of negative 34 is positive 17. And that becomes 24. And then negative half of 24 is negative 12. And that becomes 0. So this tells me, yes, for sure, negative 1/2 is a solution. Okay? All right. Now I'm going to test 3/5. I'm trying to narrow down what I have left here to get it to be something I can work with and find the remaining factors. So I'm going to do synthetic division again with what I have left here, just kind of dividing out these factors with 3/5. So I bring down 10. Now you may say, yeah, but that's yucky because it's a fraction, but it's really not. All you have to do is do 10 times 3, which is 30, divided by 5, which is 6. Okay, so this becomes negative 10. Negative 10 times 3 is negative 30, divided by 5 is negative 6. That becomes negative 40. Negative 40 times 3 is negative 120, divided by 5 is negative 24. So we're getting somewhere, okay? And this is 0, so I can say check, yes, 3/5 for sure is a solution. Now I have something workable that I can work with here. Okay, I have a trinomial remaining. So I'm going to just kind of start writing out the factors. I realize that 3/5 is a solution, so written as factor form, it would be x minus 3/5. Negative 1/2 is a solution, so written as a factor, it would be plus 1/2. And then I still have this trinomial left, 10x squared minus 10x minus 40. Now again, I need to find the factors of this trinomial to fully factor this. Okay, so, but wait a minute, I notice that I can pull out a 10. So I'm going to do that. I'm going to pull out a 10. I'm just going to stick it right in front of that trinomial and say I have left x squared minus x minus 4. Now I need to find the solutions or the factors of this trinomial. And guess what we get to do? It is not factorable. There are no factors of negative 4 that add to negative 1. So we get to use the quadratic formula. Aren't you excited? So come up here, all right? And I'm going to just write down my A is 1, my B is negative 1, and my C is negative 4. And when I plug in to the quadratic formula, it's going to look like this. And when I do the quadratic formula here, I end up with this, and it can't be really going simplified any further. We'll just leave it in that form. It's 1 plus or minus the square root of 17 times 2. So if I write those solutions separately, it's 1 plus the square root of 17 over 2, and 1 minus the square root of 17 over 2. So now I finally have my 2 rational and 2 irrational solutions. And if I wanted to write out the polynomial in factored form, it would be f of x equals x minus 3/5, x plus 1/2, and this is going to get kind of messy, but it's okay, x minus 1 plus the square root of 17 over 2. And then I'm going to have to come down here. Actually, we might want to do that in brackets because we got parentheses inside there. Times x minus 1 minus the square root of 17 over 2. You don't have to write it out in factored form, but that's what it would look like. All right, so all you did here was use the rational list of possible solutions, simplified it, tested a couple to see if they gave you a remainder of 0, to narrow it down to a trinomial that you could finish off the problem with and find the rest of the solutions. That was with a leading coefficient of 1. This is with a leading coefficient of not 1. It just gives you a whole lot more possible. And then again, you go to your calculator, you find a couple that really are true, and then you just show the work for the other two. All right?